Hello there. This video is somewhat a continuation on my projects involving weird floppy drive setups, like the one I did about connecting 4 floppy drives to your computer, or the one that I did about adding a switchboard to allow you to manually switch between 2 floppy drives. Because today we're taking a look at this, which is a new floppy controller being developed by TexElec. And, well, let me just start off here by listing some of its features. It is a dedicated floppy controller without a bunch of unlabeled jumpers that you have to figure out how to use to disable peripherals so they don't collide with the ones built into your motherboard. It has an 8-bit ISA interface, so it'll plug into any motherboard with an ISA slot without worrying about the little 16-bit section hanging over and hitting chips. It has 2 floppy headers that allows you to connect up to 4 drives using the IBM PC interface with twisted cables. It has a BIOS option ROM that allows you to configure how these drives show up in DOS without needing to deal with a weird secondary controller. It also has optional adapters to allow you to interface it with 8-inch floppy drives. And it has a detachable and remote mountable display on it to show you exactly what it is doing with the floppy drives. So, there are a lot of things built into this controller, and I gotta say, it's probably my dream floppy controller. Alright, as you can see, we have a lot of things to get through to really explore this card. So we're going to start out with the quad flop in my test bench here, because this is going to give us a lot of options to play around with here, including that floppy switchboard that I made to demonstrate that working with it as well. But first, let's go ahead and take a look at the card itself so you can get a better feel for what exactly this is. So this is the quad flop that TexElec is working on, and hopefully it's going to be available soon. There are some parts supply shortage type things that are holding it back, unfortunately. But this is going to be a really great option for using with your vintage computers. Now, at the core of the quad flop is the floppy controller IC, a PC8477BV, which is identical to the one that is in this 4 floppy controller that I showed in the video all about this subject. And this is such a worse experience to use one of these because of those unlabeled jumpers. I'm not kidding when I complain about that. The one that's in my 46 now, I unjumpered and jumpered every single one of them to try and figure out which ones disabled the peripherals on here, the serial parallel game port and all that stuff, so I could just get that card to be a floppy controller. So having something that is just a floppy controller is genuinely really nice. Now in this area, it is a bit more than just a floppy controller, because there's actually an MCU here that snoops on what's going on with the floppy controller to display information about what the drives are doing on this 7-segment display, and it's kind of awesome. And this display can be disconnected. It can be broken off of here with the mouse bites, and then you can add a surface mount header back here and then run a cable to connect the header if you want to move this somewhere else. Since my main use case here is in a test bench, I'm going to go ahead and leave this in there, but there are a lot of options that you could use with this, which is really cool. But we'll go ahead and see what this looks like in a moment. But in general, this shows the kinds of things that you would see on a GoTech, so tracks and sectors being accessed. So it's pretty cool to see. Another thing that I really like about this is that it is self-documenting with the few switches that there are to configure it here, and I'm only saying few in that it's relatively simple to use overall, and actually I don't need to change anything even, and everything is very well commented on how to use this, and that is related to the 8-inch stuff that we'll get into later. But yeah, we have pretty much everything we could possibly need to know about this, and it's just very nice to have all of that on there. Now though, let's go ahead and put it in the test bench so we can see it in action. Now, a quick note on how I'm going to be designating the drives in this video and which drives are here in the test bench. When you start to deal with a 4-drive controller, calling this A and this B gets to be a little messy when you then have the hard drive become C and then an optical drive become D, and then the 3rd and 4th floppy drives get pushed all the way to E and F. So instead, I'm going to call this drive 0 and this drive 1. Now, in the test bench here, drive 0 is a 1.4 megabyte drive, and drive 1 is a 1.2 megabyte drive. Drive 0 can actually be switched between the real floppy drive and the GoTech using this switch here, which is connected to one of my floppy switchboards that I have a video about if you want to make one of those yourself. And I could actually have both of these connected to the Floppy controller we're using today and just access them directly, but this is how I prefer to leave the test bench set up, and it's all kind of wired in there. Plus, this frees up the entire secondary connector for connecting to other drives. The motherboard in the test bench is a Super Socket 7 system that has 16-bit ISA slots, but that's not a problem at all. And I will go ahead and connect the internal floppy drives in the system to the card now. A quick note, if you're going to use an add-in floppy controller like this, you do need to disable the onboard one for the motherboard, which you can usually do in the BIOS. All right, I'm letting the test bench fire up here, and you'll see the card initialize. And there we are. Now, as the system's booting up, you can press F2 to get into the configuration menu. Now, once we're into this config utility, which runs directly off of the card, you don't need drivers for this, we can see that this is using the multi-floppy BIOS by Sergey. And this BIOS is available on GitHub, where Sergey released his monster FDC board, which is an 8-drive floppy controller. Just wow. I'm happy with 4 drives. I don't really think I would ever personally have a use case for 8, so I'm going to stick with a card like this. But there is that one out there too, if you want to go and make one. But what that means is that the BIOS can be updated later as well. Now, when we're in here, we can print a list of how the floppy drive controller is currently configured, and we can see that I have it set with drive 0 is a 1.44 megabyte drive, and drive 1 is a 1.2 megabyte drive. Now, you can change these configurations very easily. So let's just say we want to delete drive 0 here. So there's 2 things that you need to note. There is a logical drive and a physical drive. So we're going to go ahead and delete logical drive 0, which was the 1.4 megabyte drive. Then we can print our listing. And now drive 0 logical is the 1.2 megabyte drive, which is actually physical drive 1. So you got to separate the logical and the physical drives. We can swap these as well. So we're going to go ahead and add a drive. We're going to enter physical drive number 0 for the 1.4, and we're going to make it logical drive 1. So we can now also choose the capacity of the drive. I will be using a 4 for a 1.4 meg. And now we can print this, and we can see that the way that the BIOS will present this to the computer is the 1.2 megabyte drive as drive A to DOS, and the 1.4 megabyte drive as drive B to DOS, even though they're actually wired the opposite. So we'll go ahead and just write that just for giggles and see that in action. Okay, now that we're booted into DOS, I'm gonna go ahead and take a 1.2 megabyte disk and pop that in the drive. Now for us, the 1.2 megabyte drive is drive A, so I can dir A here, and it does access the 1.2 meg drive, but if you look on the card's display there, it will say that it is drive B. And that's my fault, since I swapped those 2 drives for giggles, just to show you that's possible, because it is snooping the physical lines going to the floppy drives, and it has no idea what the BIOS has done, because that would take way more complicated stuff going on that would just raise the price of the card for no particular reason. That chip that's in there is not capable of snooping the ISA bus, which runs way faster than just the access for the floppy drives. Now, one thing I do want to do here is I'm going to go ahead and format A, and you'll see how the display works fully here. So as I format this, it will continue to show B, but it will go through all of the tracks on the disk and list them off as it works through them. And there we go, track 0 through 79, formatting complete. So there it is, displaying the tracks, which is really cool. Now let me show you it switching between drives, but I'm actually recording this after doing a lot of debugging on that, because there was an issue with it resetting when it tried to access the drive 0 drive, and after way too much troubleshooting, I've determined that actually, what I was about to say here doesn't really matter, because it turns out this was probably caused by a one-off bug that will have only affected my card. So we're just going to go ahead and skip past this part, because The production card shouldn't have this issue. Here, you can see it is on drive B, and I have now undone the weird crisscross stuff, so you don't have to worry about that. But we can go over to drive A here, and you'll see there it is, accessing drive A and reflecting that on the controller, which is pretty sweet. So you can watch that and see what the system's doing with floppy drives, which is really cool. So there's what 2 drives looks like on this thing. But that's not what really makes it cool. What makes it cool is 4 drives. So we're gonna connect a second set of drives here, a 360K drive there and a 1.2 meg drive there. And I've already gone ahead and gotten power and data cables for these. So all I have to do is flip this over to get power. And then I have a longer floppy cable set up here that I'll run in through the back and plug into drives 3 and 4. So now I can power this thing up and then get these added to the BIOS so we can access them. All right, now that we're in the BIOS config, we're gonna add this drive as drive 2 because it's at the end of the cable, so it's the lower number. And then this drive is drive 3, 2 is a 360, 3 is a 1.2 meg. So we're gonna do A for add, we're gonna add 2, and it's going to be the second logical drive as well, third, 2 ID, yada yada. Let's see, 360K, all right, print that, see what we've got. Perfect, okay, we're gonna add 1 more, and just for the record here, if you are curious, we're gonna press 0 and it's gonna tell you that it already exists. So you cannot overmap drives. So you do have to enter in each one uniquely. But we're gonna do 3 now, and then we're gonna do 3 again here. And this will be set to 2 as a second 1.2 meg drive on this system. There is our config. That all looks good. W to right. And now we will reboot. Now, the way this BIOS works, it does not automatically add these extra floppy drives to the systems list that it creates. So if I try and go to F here, it's gonna say invalid specification and not even try to access the drive. So we can either just use these directly through disk imaging programs, or we can use the exact same driver.sys file that I recommend for the floppy switchboard, or another one that's available that I believe is part of the SD IDE package. We'll take a look at that. This time, edit config.sys. And this can be set up like this. Now I'll provide a link in the description for this driver because it works a little differently than the driver.sys one, and it might actually be compatible with other DOSes as well, which is one of the reasons why it's worth checking out. But it also has some different device descriptions. So this is the second drive ID, and if I'm fully remembering correctly here, the documentation for this, 1 is for a 360K disk, and it has an option for 0 to be a 180K single-sided double density disk. So we're gonna use this, and then P means primary controller instead of secondary. So we can activate this to get our primary 360K drive working. Copy, and then paste. And I'm just gonna change this to, I believe, 2 for the 1.2 meg drive and 3 for that ID, and then we will go ahead and save and restart, and now we should be able to access both drives from within DOS. And there it is loaded. Do note I actually made a mistake there. Don't duplicate the whole line, just add a second device initialization parameter to the same line. That was wrong, and it made the system lock up. But with it in here now, we can see that we have a drive F and a drive G for the floppy drives. But we can test this, so we can see drive F is our 360K drive. So I'm gonna go ahead and put a disk in there, and dir F, it's accessing it, and boom, a drive listing from a 3rd or 4th drive. I can take the 1.2 meg disk that we formatted before, put it in the other drive, and dir G, and we should see the test label. There we go. So 3rd and 4th drives are working. How sweet is that? Now, the main use case for this is to have all 3 different kinds of drives here, a 3.5-inch drive, a 360K drive, and a 1.2 meg drive for disk imaging. And then we use that 4th drive connection for an 8-inch drive, which is a whole other ordeal, but we'll get to that in a moment. So that is why you'd want to do this. So let me go put IMD on here, which is a disk imaging utility that I don't normally use, but I want to give it a shot for this for those 8-inch discs when we get to them, because I think it handles those better. But yeah, let me pop that on here. All right, I've got the disk imaging utility on there now, so we're going to do cd IMD, and then we're just going to run IMD. Okay. I'm going to make a long story short here and say I couldn't get IMD working with the 3rd and 4th drive, even though the help says that it should be use both drives C and D. It would cycle only between A and B in the drive menu. According to the manual, it may be possible to launch it with a parameter to directly specify drive C or D, but I didn't know that at the time, and I'm more used to Mike Brutman's DSK image, so I opted to switch to that instead. So I'm actually going to edit R360.bat here. And what I'm going to do is I'm going to change the ID for the drives. So normally I would have the 1.4 meg drive be 0 and then 360 be 1, but we're going to change this to a 2, which I believe will do this and make it work. I don't know that I've actually tried this, but this software is pretty good. All right, now that that script is modified, I'm going to take the 360K disk that we just read earlier, and I'm going to pop it in there, and we're going to go ahead and disk image it. So I'm going to run the script, r360.bat. It's going to load. It says it's working with drive ID 2, which will be this one, and everything looks good there, so I'm going to run it, and there we are. We are reading the drive. And I didn't show you this before. The drive does show E when you're accessing ID 2, and if we access ID 3 here, we can see it switched to F. So it will show the individual tracks that it's accessing for each drive, which is really cool. Now, the more typical PC drives here are fun to play around with, but I think it's time we take a look at the adapter that allows us to plug in 8-inch drives. Now, I'll caution this is probably one of the parts that's still more in development, and I'm not sure how you're actually going to get the 8-inch adapter, so it may be a separate thing or not. But this is designed specifically to be used with the quad flop here, and the quad flop also has an option for this. Now, using the 8-inch drives with a standard PC controller can be a little weird, and they're not the normal sector layout and stuff. But one of the big things is that they have this 50-pin connector to connect to the drives. And if you want to plug this directly into a drive, it has a card edge connector like that. And there is also a power adapter being made available. So the power for an 8-inch drive is actually 5 and 24 volts, and 24 volts, not exactly possible to get out of a PC power supply. So you need something weird, and then that's the power connector. It's not just, well, it may be Molex. I don't actually know who the manufacturer is, but it's weird. So connecting an 8-inch drive is not completely trivial. And then there are a number of settings that you may or may not need to change in order to get this working. So 8-inch drives are kind of a whole other thing, and I'm not going to get too deep into this video. I'm mostly just going to demonstrate that this works because, yeah, there's way too much to get into here. Now, I've taken the top off for a moment so you can see what I have for drives here. These are 2 of the drives that I got with my CompuPro and IMSI computers, and these are 2 Cumtrack, is it 842 drives here. Now, these I've had to actually work on a number of times. 8-inch drives are very finicky for some reason, so getting these working even is kind of a pain in the butt. Now, since these are in this integrated chassis, I'm going to be using the internal power supply, so I'm not going to be using that other power cable for right now. And unfortunately, I can't really directly connect these either. It's not the easiest thing to see here, but you'll notice that I've hot glued this connector onto this drive down there. And that's because for some reason, the gold fingers are actually wearing off of the connector. So I found a position where it was good and then glued it in place so it doesn't move anymore. So I don't want to remove the cable from either drive here and mess with anything. Both of these drives work in here, and I want to keep it that way. So what I'm going to do here is I am just going to use the external connector on here, and I might as well put the top back on because we're just gonna leave it like that. And we're gonna use this as a complete unit like this. Now, I've got this cable plugged in there, so I can go ahead and plug it in here as well. Pin 1 is marked, and I'm matching the location of the red stripe on the cable, so that'll match. And now I can plug the 8-inch drives into the controller there, and we can try this out. 8-inch drives, since they use the original Shugart interface and they don't have the twist in the cable, have the motors running all the time. So I'm gonna get this turned on so those can start spinning away. So there we are. I have reformed the capacitors on this, and that's another thing I need to make a video about. So I'm not worried about the condition of the power supply on this, but just letting you know. Okay, now that everything is set up here, I'm gonna get into the configuration utility for the card, and I'm gonna set it to two 1.2 meg drives for this, because I think that's the closest size that we have as an option. So I'm gonna print. We're going to delete drive 2. All right, we're gonna add drive 2. We're gonna set it to logical 2, and we're gonna set it to 1.2 megabyte, print. So now both drives on the external drive interface, or the 3 and 4th, are now set to 1.2 megs. So we will give that a try. Why is this not recording? Cool. Okay, so we're now gonna try and image this disk. This is a copy of CPM 86 for the CompuPro, and validating a successful disk image is really difficult for CPM stuff and 8-inch stuff in general, I've found. Because there's no consensus on emulators and disk formats and all that kind of stuff. So there hasn't been any one clear victor of a way to image these. So generally for these, I'm probably gonna settle on raw flux data from something like a CryoFlux or Grease Weasel, but we can actually image this on here. Now, I was really lucky on that particular disk, which is an MFM formatted disk, which means this controller can fully read it and not have any problems. And since I've already fluxed imaged that disk, and it's even on archive.org already, I know exactly what the layout is. It is an 8-sector MFM disk. And I know this drive also has 77 tracks. So what I've done is I've gone to the DSK image folder here, and I've created an R8-inch mat file. So I've set this up for drive ID 2, which is the farther away drive here, with 77 tracks, and one I'm pretty sure is single-sided. It's been a little while, but I believe that's what that is. And then 8 sectors, so that should work. And I'm realizing my video capture just failed me, so I'm gonna just shoot off the screen here for a moment. So, it should attempt this. Head loaded. And single stepping. It's actually reading the drive. Okay, so I'm guessing IMD decodes the sectors. And now this makes sense. If the first sector was 26, I didn't look too hard at the flux map, so that could be why it wasn't working right. All right, read complete. I think we just read an 8-inch disc on DOS. Okay, and I'm gonna pull the SD card out of my test bench and go check out what the files look like. Okay, so I've got the card in here, and we're just gonna see what we can get. IMD 8-inch.imd, and what I'm gonna do is I'm actually gonna open this in a hex editor because I don't know what on Linux we'll be able to just open an IMD image. So we're just gonna search for strings in here, I think. Oh, we don't even have to. Boom, CPM 86 1.1 NA. That totally worked. We have an IMD image of the CPM disk. That's kind of awesome. For giggles, I'm going to drag it over into HXC, but, oh, HXC knows what an IMD is. Okay, well, sweet. There are some CPM tools for Linux, but I don't know fully how to use them, and the CompuPro stuff has a weird format, but I'm pretty happy with that. That was successfully imaging a CPM disk from DOS using the Quad Flop. Well, there we are, the Quad Floppy by TexElec. This thing has a lot of features packed into it. I'm looking forward to the final revisions coming out and people being able to get them, and hopefully all the little quirks get sorted out. It's been a lot of back and forth on things, so, you know, development type stuff, but this is looking extremely promising, and I'm really happy that I've been able to try it out. So definitely something to keep an eye out for. But that's it for now. If you enjoyed this video, you may want to subscribe, and if you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time.